Hello, 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 everybody. Welcome to Cloud Native London. It's a beautiful new year, 5th of January. Everybody pump it up with the new resolutions for better tomorrow and a better day. I hope so. Welcome, welcome, welcome. So let's have a look what we're doing today. Welcome everybody. This is Cloud Native London. If you want to join, you want to with everybody, you want to feel like a real meetup, please go to oyshow.com/r. There's a Rambly. You can create a virtual avatar and you can meet with all the people what they currently watching and listening, and you can talk over and maybe you can catch our speakers there. So cool place to be. And what we look at. So today, as always, we start at 7. Quarter past, we'll have a speaker. As you can see, there is a lot of good topics today. We'll start with the tools. Then we will start talking about the deployment of the Kubernetes, and then we'll be debugging Kubernetes, which is already something what probably everybody who is dealing with this beautiful tool. Well, one day we'll have to do it. So welcome. Who we are. We are a strong, open, diverse developer community dedicated to the cloud native platform and technologies based in London. Right now, we have this magic thing outside what it do not allows us to have a meetup with face-to-face. So our lovely community, now it's in a virtual. So join us from wherever you want, and so we are open, and please let us know from where you are. My name is Hubert. You can see this is my Twitter handle. I will be your host for tonight. Please have a look on our agenda. This is what we'll be doing. First of all, I want to say big thank you to our sponsors. What they help our meetup still going, even in the middle of pandemic, and hopefully when this will get over, we will meet in the real person. So I would like to ask David from Palo Alto. Please can you give us a shout out about your product?
Well, thanks very much for having us again, Hubert. It's always a joy, and thanks for Happy New Year to everybody else. Yes, so Prisma Cloud, part of Palo Alto Networks. It's the division of Palo Alto Networks, the security company, which is all about cloud, or code to cloud as we call it now. So securing your cloud native deployments, and also looking at likes of infrastructure as code, vulnerabilities within images, and much more throughout the life cycle. So appreciate you all allowing me to give a little 20-second intro today about Prisma Cloud, and enjoy the session.
Thank you very much. So if you look for security, look no further at Palo Alto. But we have a Zan from Cycle CI. Zan.
Hello, and yeah, Happy New Year from my end as well. I'm from Circle CI. We're the world's leading CI/CD platform, helping teams like yours, hopefully, build, test, release, deploy software, whatever language you're using, wherever you're deploying it to, we've got you covered. We've got some pretty cool news coming up in the next couple of weeks, so keep your eyes peeled on @CircleCI on Twitter, or circleci.com. We'll be sharing some stuff in the next couple of weeks.
Fantastic. So if you look for the CI, not look further, and keep tune on in for new exciting things. There is a Humio. Unfortunately, I think Laura couldn't join us today, so let me give her a shout out. Pulumi is a time series log management solution for unrestricted event analysis scaling to multi-terabyte per day on premise and hosted. We have a very talk last month from Humio. So if you want to see how it works and feel how it works, go back to, you can watch on YouTube on a VOD from the December presentation. It was really interesting. So guys, as always, we have reaching now to our beautiful audience. This is the link, oycheryl.com/p, where you can go and see, and you can, where we'll ask you to participate to a few questions. Don't worry, nothing. You know, there's no curveballs. Anything we'll have a little bit want to know about you, and do questions from our speakers. So please, oycheryl.com/p, very simple link. Go there, register your name, and we will get from there. Again, it's very simple poll when about and with a very few questions. And one more time. I don't think that everybody needs it. So let's move on and see how everything will pay off. So, is your first time in the Cloud Native London? Please let us know if it's your first time or not. Hopefully we'll have some mix about the people. We have a 50-50, which is already nice. Welcome for people who are the new joiners and the people who are already been with us for the long time. So welcome everybody. I hope that everybody feel welcome. Oh, we have a more votes, 50-50. Oh, we have a more than no. Welcome. Oh, that's interesting. It's very interesting. So welcome new joiner. Hopefully you will see and learn something new, and hopefully you will come back in the next our CNCF meetups. So fantastic. One more minute because I still see that this is moving a little bit. Right now I am surprised that this is 33 to 67. Again, very warm welcome to everybody new. But okay, 5, 4, 3, 2, 1. I think that is enough. It's stable. Next question. Where are you now? Again, this is Cloud Native London, but we are virtual. Please point on the map. Where are you? And so we can see how far we can reach. Oh my! In India, England, and I think they will be somewhere in Middle East, like Israel. Someone in the north of the Canada. That's interesting. Welcome, even from the cold Canada. If you do this my mistake, or you can always change it. But yeah, that's very lovely. Strong representation of UK. But yes, again, we are virtual. We are all over the world. Welcome everybody. Glad that you join us. So, what's your job title? And I think that always this is the options. What we have here. It's let's choose what is the best one. But even if it's not something what you can fit in. Please try to choose order. If you are older, please drop on the in the YouTube or Twitch chat what is order. We would like to hear from you. If you want to have a link and you watch us on YouTube, please look down below the stream. There is a link to Rambly, also to Paul. It's Yshay/P. Please. Developer advocate. That's nice. I think that's. I love the name advocate. It is. It's always sounds very, very nice. We have a very strong SRE DevOps engineers today. That's not very common actually for us. Head of R&D, welcome. That's really, really nice place to be, especially for CNCF meetup. And with the topics what we have right now, hopefully it will be very, very handy. Full stack engineer, really welcome. And I always say that in the modern times when CNCF growing, it is one of this thing what it's good to know, even if you're full stack engineer and it's sometimes it can be overwhelming, but hopefully it's just this kind of one gigantic jump what you have to do. But after that is everything just much more simple. We have more architects, which is fantastic. Performance engineer, that's something. That's a lot of my respect, because I know that this is a very hard job, especially not very. I think not only, but a lot of respect need to be paid for the performance and QA engineers, as their job is not always rewarded, I would like to say, in the way how they should. But yeah, that's fun. Kubernetes cluster breaker. I just break them for fun. Okay. That's can be as well. If you've been paid for that, I'm glad for you. All righty. I think the poll is stable. We can go further. So this is the question from right. Yes, now it works. All right. Who should own troubleshooting in Kubernetes issues of the age of the DevOps? This is a question from our speaker today. So this is Itiel. That's very interesting split, 50-50. So yeah, no one choose DevOps, which is very interesting and more. Okay, I think I spoiled the water. Itiel, can you tell us what did you expect from this poll?
I think it depends on what people are like the audience, and as most of the audience is DevOps, it seems like they don't really want to troubleshoot, right? so I will say it really depends on who are you asking.
But what you're saying that if there is a SREs, that you will say developers and developers.
SRE, yeah.
It's like a hot potato.
I will say no one really love waking up in the middle of the night, right? So I will say people try to move the potato. I'm really in the mentality of you build it, you own it, you troubleshoot it, right?
Oh, really? Okay.
So it is much more like my personal opinion is that developers who write most of the code should handle a lot of the troubleshooting. Obviously, some part of the troubleshooting should be done by the SRE.
Right. Okay, that's interesting. I can from my as a DevOps and SRE at the same time, I can say that I don't know which option I will choose, to be honest, because I will say it's a half and a half, because I feel as a SRE I feel obligated to make sure that everything is running. and did at least like a beginning of the troubleshooting, and then hand over if I can't fix this, hand over this to the developers as an example, if you know what I mean. But yeah, that's in the end, we have, as we can see, there was a lot of SRE engineers today, nearly 50% of our audience. So yeah, look, 57 SREs and still moving, which is very, very interesting. To 1 more minute. Anybody else would like to vote? Okay, can we seal the results? I think that it's enough. All right, that's very interesting in my opinion. But as you said, that 50% of our audience is SRE and 50% should be responsible for troubleshooting. That's maybe that says something. Right. Next question. What's your favorite way to configure Kubernetes application? Plain YAML, ham, Pulumi, and order. And we are curious, if you choose order, please let us know in the chat, because that's something what I will try to read in the chat for YouTube. That's interesting. So, Yshay, if you'd be so kind and tell us a little bit about why everybody hey YAML and why they want to choose something else. I think you are muted here. So
yeah. So basically, I believe that most teams will use the combination of some of these tools, especially plain YAMLs or Helm chart. So that's why the question is, what's your favorite or least terrible way to configure a Kubernetes application? It seems like Helm is incredibly popular. I believe that Helm chart or customize, most users use Helm rather than customize. I assume, I'm not sure about that, but I would be surprised if it's different. And I was curious to see like how users like define their deployment in different way, and we see that they're like Helm is certainly at the top, but other tools are used as well.
So one of the notes what I have on the chat, the question is a little bit ambiguous. So let's say, I think there is the best way. It's just how you like to deploy your application. So if you would like to have a plain YAMLs, or you want to use tool like a Pulumi, completely not related that we have a speaker from Pulumi, but there's a Helm chart, and but okay, so now I think this is a little bit more stable, and I can't poison anymore water. Can you let us know what you expected, Yshay?
So it's pretty similar to what I expected. Okay. I thought maybe plain YAMLs will be a bit higher, but it's actually very similar to what I expected.
Oh, okay. Anybody else want to vote? 5, 4, 3, 2, 1, and I think that's it. So looks awesome. I think that in the last question, the controller manager allows disabling individual controllers. Which of this is a real controller? Oh, that's a very that's very interesting. David, I believe. Why there is no option is just like what we're talking about, for example.
Yeah, not a lot of people understand the responsibilities of the controller manager and the fact that it's responsible itself for so many subcontrollers. I thought it'd be fun to test a little bit of esoteric knowledge here.
Yes, I think that Yeah, I think if there's no one knows which option to choose, I think that they can drop the answer "I love pizza" in the YouTube chat, so we will know. We'll know how this is going. If so people will not feel shy. Don't worry. I would like to say the most important thing is. Don't worry, everybody. We are here to learn. So if you don't know the answer, that's completely fine, because everybody starts somewhere. And I remember when the Kubernetes is not even version 1.0, and basically you have to recompile every single thing by yourself, which was very interesting. But everybody starts somewhere. So if you don't know, that's completely fine. And I think now that again looks very stable right now. So David, can you let us know what kind of answer you've been looking? What the kind of answers you've been looking for? I don't ask which one is true right now, but can you tell us what you expected?
I kind of expected a lot more people to vote for attach because it doesn't sound like a controller. But yeah, a lot of votes for RBAC though, I see.
Yes. Let's give one a minute maybe, so we will see that people are voting. But I think that looks stable. So can you give the answer for this question? David?
Yeah, the audience is correct. RBAC is not a controller. There's a few curveballs here. The replication controller is
I think the people now changing.
Yeah, the curveball here being the replication controller is now defunct. It's been replaced by the replica set controller. Attach is responsible for some storage, and we've got pod garbage collection. That's the obvious one there. But if you take anything away from this poll question, it's that hopefully you've looked up the docs on the controller manager, and you see you can disable these individually, which is a whole lot of fun for breaking clusters.
Definitely, because it's one of these things. As an administrator of the Kubernetes, you have to break a few times before you put something in production. All right, I think so. Hopefully, if you didn't know the answer, hopefully you learned something. So yeah, let's start with our first speaker. We will give you a little bit more time because our polling goes very, very well. So Itiel, are you ready? I think you are muted. So if you be so kind, I unmute yourself and share your screen.
I just unmuted myself, so no problem.
And please share your screen so we can see it.
1 second, and I'm sharing it. Okay, I can't view my screen.
Let's give a second. It's starting. Oh, no.
Did you saw my screen?
Not yet. Can you try once again?
Yeah, I'm doing the share again. Now can you view my screen?
Yes.
And now I'm presenting, and you can still view my screen.
We can see it.
Okay, amazing. So hello everyone, happy to be here. So let me start by giving a very quick intro about myself. My name is Itiel Shwartz, and I'm the CTO and co-founder of Komodor. We are a startup trying to build the first Kubernetes native troubleshooting platform. And that basically means we help developers, SRE, DevOps to troubleshoot their Kubernetes cluster much more easier, faster, and without the pain that current troubleshooting required, pain and time. And I really like and believe in making developers more productive, more empowered, and basically to build them tools so they can move fast. In my past life, I worked for eBay, Fortran, Rookout as the first developer, and I come from a very rich background of backend and DevOps experience. I basically started as a backend engineer and slowly transitioned into more of an ops operations world. And I really like Kubernetes. Over the last 6 years, I think this is pretty much everything I do. So I think that like it's no big surprise to anyone who is listening here, you know, and the cloud native code is being released much faster. And very nice thing is that we are releasing more code faster and to much more distributed world, meaning not to a single monolith like that keeps on changing, but to a vast variety, which is the modern stack composed out of microservice, databases, cloud providers, and so on. And in the middle of everything, in the middle of this like very big revolution that we're currently in the middle of, Kubernetes is basically the new king, or like the king of the block. I know that there might be some serverless fans here, or ECS fans, but or Nomad, I don't know. But in the end of the day, Kubernetes is pretty much becoming the de facto standard of cloud native. We see more and more companies adopting Kubernetes. They are in Kubernetes, or they are doing a migration process toward Kubernetes. And this is the ecosystem that we live in. And this is I'm going to focus mainly around Kubernetes on this conversation, even it is true for other systems or other like modern systems. So like Kubernetes, the good and bad thing about it, it looks very easy and neat and fun to get started, right? You view like a very simple YAML, you are deploying it, you see your application like just like running, which is amazing. But in the end of the day, what usually happens for like companies moving to Kubernetes and not like someone doing a small project at home, they start really happy. They are saying, oh, the deployment is so easy, everything is YAML, everything is code. Like there is this like this high when you see how everything looks really good. But then in the end of the day, like you have the day 2 operation usually, and you start to realize that you don't really know what is happening in Kubernetes under the hood. And it was all like good and sunny as long as the application ran normally. But once it starts having issues, once your pod is not getting any traffic, you start like wondering yourself, like, how did it ever work? What is this ingress I just used? What is this load balancer? How they connect to one another? So this is what like most organizations that are transforming to the cloud, this is what we see. So if you are like in here or in here, just know that it makes total sense. We see hundreds of different customers, and every single one of them are experiencing pretty much the same like road of like super happy, super sad, and then quite happy, because Kubernetes is a good platform, at least in my opinion. So let's say you just move your application from whatever into Kubernetes, and now your application is crashing, your cluster is crashing, your customers are shouting at you. Who is responsible for the troubleshooting of Kubernetes problems? And we had it in the survey, right? And there are like 3 like main suspects. We have the SRE, we have the DevOps, which is not really a job position in some companies. You can argue and say that this is a cultural movement, but a lot of people do call themselves DevOps. And there in the end, there are like the developers. So it's a very interesting like questions, and a lot of companies don't really spend a lot of time thinking about it when they are starting their like moving process into Kubernetes. They are like, yeah, I don't know, the DevOps so far like troubleshoot our system, so I see no reason to switch it. And the SRE will handle the very like complex issues or problems. But then what happens is that they realize that the DevOps are outnumbered by developers. And for each DevOps, you have like 10 developers. And till Kubernetes, maybe there were a lot of guardrails stopping developers to push to production. Everything was slower. But now we have 10 developers, all of them really like, I don't know, deploying code into production. And the system is changing very rapidly. And the people who once had like they knew every change that happened in their system, the DevOps or even the SRE, are now quite a little bit like blindfolded, and they don't really know what is happening, what should they do next, and how do I troubleshoot it. And then what we see in a lot of companies is that those DevOps or SRE are pretty much the organization bottleneck. They are the ones that while in vacation with their family are getting like the call in the middle of the night, hey, I have some problem with my cluster. What do I do now? And as we see more and more like tools that allow us to deploy faster to production, this is only going to escalate, right? Because the DevOps can't really be expected to know everything and to handle everything in those systems. So like, I'm sure that I know what everyone thinks, like, so, okay, so there are a lot of developers. Why won't we give them like the responsibility? Troubleshoot your system, please. Just leave the DevOps and the SRE alone. So there are 4 main reasons why it is not happening most of the time. I'm going to go over each one of them in details in the upcoming slides. And it starts with the lack of Kubernetes knowledge. So simple as that. When people don't really know Kubernetes, it is very hard to expect from them to troubleshoot it. Like, I think it makes total sense that if you don't know it, how would you troubleshoot it? In a lot of organizations, we see a lack of permissions, and we see that the developer simply can't access the Kubernetes cluster. So again, like, how are they expected to fix Kubernetes-related issues? There is the problem of a cultural problem. Developers, some of them, don't really want to troubleshoot. They are not encouraged to troubleshoot. They are being measured about the number of features that are writing, and maybe how little bugs they are writing, but not about their troubleshooting skills. So we need to train or to shift a little bit the mindset of the developers toward a more like ops or troubleshooting phase. And lastly, most modern troubleshooting tools were meant for DevOps, not for developers. And there is like 2 different languages that is pretty much that are pretty hard like for developers to go into the DevOps mindset and DevOps tools, as it wasn't really designed for them. Okay, so let's start with the cultural mindset when it comes to incident response. Again, I don't think I really need to explain it too much, but looking back 5, 10 years from 10 years ago, the ones who are pushing the code to production were the DevOps or the IT or the ops, doesn't really matter. So developers wasn't really expected to troubleshoot his code because he didn't really know when his code is moving to production. He was not part of the process. It couldn't be like a deploy cycle of a year or like very long releases. So it was really an ops problem back then. But now the developer is the one that is changing the environment. Now the one who is to blame is not the ops guy who just switched the disk, but the developer who just pushed his code into production. And we need to train developers or to make them understand that their responsibilities doesn't end when they are pushing their code into production. It doesn't end when they merge their code from the feature branch into master, but they need to be responsible even after their code is live in production. I think that for like young people, it's easier, like for developers who come like from a cloud native, I don't know, like world that they are still fresh. For them, it's really obvious, like, okay, you know, like I built my code, why won't I troubleshoot it? But for like more of like old-fashioned people, it is hard. And I will say that the other way is also tricky sometimes because the DevOps sometimes doesn't really want to let go. They will love the power that they have. They love being in the middle of things, and they don't really love giving this like power to the developers. So the cultural shift is like 2-sided here, both the ops and the developers. Another problem is the fact that DevOps tools simply doesn't speak developer language. So DevOps tools, and when I say DevOps tools, I mean like are like the tools that are beloved in the CN, right? Like Prometheus, Grafana, Datadog, New Relic. all of those tools are more ops oriented, at least in my perspective and from customers that I meet, mainly because they are very, very macro level like oriented. They want to give you all of the information, very high level. And this is the screens, this is the graph, go figure it out. A developer is usually much more familiar with his own application. He knows a very small portion of the world and he's very good in this small portion and maybe a little bit to the sides. So the main problem here is that most tools were built with a mindset of DevOps and operation people and not developers. And it's like an historical scene, I can say. We do see a shift in the new tools that try to put the application or the service in the middle instead of like the high level macro overview, which is important, but for different people. How can we bridge this gap between the developers and the operation teams? So we already talked about the fact that we want developers to troubleshoot, right? Because there are a lot of developers, they are changing their production rapidly. And in the end of the day, if they're not going to troubleshoot, the DevOps is going to quit because he can't troubleshoot everything by himself. So we want to have this. On the other hand, we see a lack of tooling and we see a lack of cultural mindset. So like we don't have the tools, we don't have the mindset, but how can we still allow developers to troubleshoot? How can we still allow them to own the troubleshooting process? Let me just go back to this slide. I will say that the two slides that I didn't really cover here are the lack of Kubernetes expertise and the lack of permissions. I think it's quite clear that if you don't have permission to troubleshoot, you are not going to succeed. I see this point becoming less and less acute as organizations understand that it is important to empower your developers and to give them the proper tools in order to troubleshoot. And the lack of Kubernetes and knowledge, it's like the main pain point, I think, in today's modern world, mainly because Kubernetes is so complex. It is composed out of so many small pieces that bring like all of this like great system into life. It is hard, and developers should know like the basics. They should know the ingress, the load balancer, the service, the deployment, the daemon set. I don't really expect them to understand every admission controllers or things like that. And I think there are some areas that it makes much more sense necessary to troubleshoot. Okay, so now how are we going to bridge the gap? This was my question. And the first thing is to empower developers to troubleshoot independently. I think it is composed out of first having them like the buying from them, meaning they want to troubleshoot, they understand how it's going to liberate them. They're going to understand how they will be able to move much faster without the DevOps bottleneck. So first step, gain the buy-in from them. Then you need to go and work like hand in hand with them and to show them, how are you doing it? How are the experts troubleshooting? It might be writing it down. It might be having like training sessions. It might be developers shadowing DevOps. All of the above are required in order for the developers to have both the willingness to troubleshoot and also the belief that they can solve problem by themselves. And if you won't get this buy-in, or if you are not going to get this kind of like mentality of I can fix issues by myself, no amount of tools will be able to solve it, and like it will simply not going to work. So now let's talk a little bit about recommended tools for Kubernetes troubleshooting. We talked mainly like high level. So now let's try to deep dive into the specific. Like, so for starters, I don't believe like there are a lot of tools that come ready out of the box for developers, but you can make adjustment for existing tools to be much more pinpointed into how a dev view the world or how a dev should be expected to troubleshoot. And I try to give an example. Think about a tool such as Grafana or Prometheus. It might be very scary viewing like all of these like complicated dashboards. But once the developers know that you have two dashboards that were designed by the DevOps or SRE and the developers together, and they show information mainly about his service and a little bit about his surrounding, you can go and say, oh, I understand most of this graph. Those are metrics that I already know. And it's nice to have gained a little more like macro level view over the Kubernetes system. So we are taking like a tool that is designed very much for operation people, and we're adjusting it to a dev-like mentality. Another very good and useful tools are distributed tracing tools like Jaeger, like everything that is open tracing that allows people to view how a request was handled between distributed microservices. This is a great tool because it speaks in a language that developers can simply understand. You have a service, okay, I'm a developer, I know a service. You have a request, I know a request, and it allows you to track this request over services. It might be a little scary for people to start using, but in the end of the day, I think it brings a very good combination between the dev and the ops. And other tools that are very popular are like error tracking tools such as Sentry, Raygun, and so on. They are also very, very dev-oriented and not necessarily ops-oriented. And I will also say like one sentence about Komodor that allow developers basically to troubleshoot much easier Kubernetes-related issues. So that was it. And my take about who should troubleshoot Kubernetes and how. The short answer is whoever wrote the code should troubleshoot it. The more like real scenario example is the one who wrote the code should troubleshoot it unless the problem is much more info related, unless it is something that you can't really expect. And like you can't gain like a perfect matching of like the alerts. It is obvious, but both of those teams, like the operation and the developer, must like work together in order to solve issues, and not like trying to do like a blame game about who should own the troubleshooting process and about like it's your turn, no, it's your problem, and so on. Yeah, so that's what me. Thank you very much. I'm not sure like if I'm okay with the times, but I hope I am.
I believe you have way more below the time, to be honest.
Okay.
What we can do?
Jump to Yshay.
No. So what I will share my screen right now. So this is the question form. You can use our if you will have a questions to our speaker and to Itiel. I believe you can go to our polling page, oyshow/p, or you can find the link down below, and you can ask the question if you would like to. So we can, I think we can give it 2-3 minutes maybe something will pop up. In terms of, can you say a little bit about how you would like to see the culture change? Because you're saying that the tools what we have, like for example Grafana for logging systems, how you would like to see that this cultural and mindset change, because you mentioned that DevOps or SREs, they like the power what they had, and one of the problems were what I see, for example, with devs, they do not like to troubleshooting because they do not being paid for the troubleshooting, if you know what I mean.
Yeah, like
they are paid for by the code, not by the so by the for looking into logs and find the problem. So how you will see this kind of cultural change?
I think that the change must come from, like, I won't say like it can come from the developers, that are simply relying on the DevOps at the moment. Like good developers want the ownership. They want to see the impact of their code on the real production system. And every time they are blocked because they need the DevOps in the middle of the SRE, they are getting frustrated. So I think like the cultural shift will happen once developers understand that they own their code end to end, and not only like like you said, like getting paid by the GitHub, I don't know, line numbers that they committed every day. So it needs to come both from the developers and from a management that understand that. And I can say that a lot of the companies that I see, sometimes the developers do want the ownership, but some like high-level manager, he doesn't really want his developers to spend time on troubleshooting because his department doesn't look good if they are not delivering features, right? So it's not on his best interest to do it. In those kind of cases, you need some buy-in of someone with a more broader organization view that can push this like forward and make sure all of the company is aligned. So I think the cultural shift already exists for like new people that were born in like a cloud native world. And as the ownership, and I think like this is the key here, as the ownership is becoming more and more increasingly like acute, and developers want more tools, they want more responsibilities, mainly so they can move faster. I think we will see it coming from the developers as well, and not only from the management or from the DevOps that are simply bombarded with questions and problems.
So thank you very much. And I think that this is the very, looks like very desirable questions. Do developers and operators share a single pane of glass to understand the cluster? Or do you think the different consumption of the platform wants different views of debug?
Yeah, great question. So I will say, like, first of all, again, like shameless plug, like Komodor allows developers and DevOps like to view the same screen and the necessary customization. But other than that, I would say that they can use the same tools, but it doesn't really make sense that they are going to look on the same screens when they are troubleshooting the platform or when they are troubleshooting their system. Like if I'm an SRE and I'm responsible for 100 clusters, my home screen is going to be, are all of the 100 clusters are okay. If I'm a developer and I'm troubleshooting a problem, my home screen is going to be the service called Itiel Shwartz, and I'm going to look at it, maybe the nodes that are running my service, and maybe the cluster, and that's about it. So like, I don't believe that there are like tools currently that allow like people to view it, but it is possible with a lot of customization to gain something very similar in like modern tools.
Okay, we have 2 more questions in the meantime. Itiel, under your platforms, which methods, process, and tools do you use in practice to troubleshoot typical issues occurring most often in collaboration with the teams, devs, ops, SRE, etc.?
I would say that like the most like common practice is making sure everyone is aligned towards like what's the status and what was the status like 10 minutes ago. So I think the first thing here is to make an alignment regarding, okay, this, and this are down, those pods, those nodes, this cluster, and 5 minutes ago, this is what changed. The fact that the node was down, the fact that someone pushed the code, the fact that someone just opened a feature flag. So I think like the best thing that you can do when you have a real problem or a real issue is to make sure that there is a full alignment between everyone that is on board and everyone that like is part of the troubleshooting process.
All righty. I think that's it for today. Thank you very much for the talk. If you have more questions, please go to you can hand over to Rambly or Cheryl/R. If you're looking, there is a link down below. Intel, if you would like to, you can hang out there. So if there's someone who will have a more direct question, they will be able to ask. Thank you very much for the talk.
Thank you. It was a pleasure.
Now, our second guest, Yshay.
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 Hello.
Sorry.
That's okay.
Can you be so? I think the stage it's for you. So go ahead.
So let me share my screen.
Yes, please.
Yes, and everyone see it properly. Yeah,
All right.
awesome. So I'm Yshay. Today I'm going to talk about how we can ease Kubernetes deployment when using Deno. It's sort of like experimentation, but it's pretty nice solution. So I won't go into details into Kubernetes too much because I see that everyone here is more aware of that. It's a cloud native meetup. It is probably the most popular way to run container workload at scale today, as Itiel mentioned. And I will say a few words about Deno, which is a runtime for running JavaScript and TypeScript. It's based on V8. It was created by the same creator of Node.js, Ryan Dell, and it has some very interesting secure properties. It is inspired by browser API and the Go ecosystem tooling, and some look at it as the next evolution of Node.js. So you probably think about that, how these two technologies relate, and I'm going to talk about it today. A little bit about me. I'm a co-founder and CTO of Livecycle, a startup that builds a collaboration platform for development teams on top of preview environments. I'm a software engineer. I heavily used Kubernetes in the past 5 years. I'm also open source creator and maintainer of Tweak, which is a cloud native feature flag and configuration management platform. But today I'm going to talk about Kubernetes, on YAML, Elm, and all this messy stuff, and also on how we can define our deployment configuration in Deno, or more specifically in TypeScript. Okay, so let's start. First of all, a quick recap. When we are deploying resources to Kubernetes, we simply use some tool that create resources in the Kubernetes server, and we have controllers that reconcile the cluster to the right state. And we all know now that RBAC is not a controller. We don't have a controller for RBAC. And the good thing about Kubernetes, again, is that everything is declarative, everything is data. So all the infrastructure when defining Kubernetes, whether it's pod deployment, compute unit, or security unit, so everything is simply a resource. Every resource is described with YAML or JSON. It's extensible. We can use custom resources and support a variety of resources and extremely complex workload. So let's I'll show a quick example here on how our YAML looks and what are the problems we encounter. So here I have a simple pod, which defines like a pod that is like an image of Tetris, and it's a game. Usually, I won't just have a pod. I have something more with more resources, or I have a resource for deployment in many cases, to have like the right number of replica or rollout strategy. I'll have service to expose my pod or several pod or my deployment in a sense, and an ingress to expose it to outside of the cluster. And usually I will just whatever system I have, I will have this deployment. And we can see that here I have Tetris working. So this is a kind of application, and it's a very naive definition. In most cases, we'll have additional resources for auto-scaling, for storage, for configuration, for secret, and et cetera, et cetera. And it's already 50 lines of code, but and it will be more. But it can be even more difficult when we have a microservices architecture and suddenly we have several services, and each one of them have this YAML configuration. And you can see that there are lots of repetition here in labels, in selectors, everywhere. And for this application, which is not that large, we'll have, again, 200 lines of configuration, and that's for like a very naive configuration. So we are suffering from this YAML, And that's why in many cases we are not using YAML directly. We have lots of tools for solving this problem. And when I mean lots of tools, yeah, many tools. And there's also a list here of more tools. And I'm going to talk a bit about two popular ones, and then we'll talk about a bit about the trade-offs we make there, and I'll show how Deno can provide superior developer experience. So the popular ones, Elm, which most of you know if we look at the poll. So in Elm, we are using templates. We have a CLI for controlling their flow. We have distributed chart registries. In essence, we have templates. If you are building this, so you know that it can be a bit difficult because we have like indents and quotes and lots of parameters. But the idea is that we have a template. We have a chart that define the application, and we have values that the user can use to customize. And then we render it using a template, which is very text-based. This is quite popular, and many applications. It has like mature and wide adoption. There are thousands of public charts available, and there are charts for everything. But the concept is that while consuming a chart is okay, it's not the best experience, but it's okay. But creating one and maintaining it can be a nightmare if this chart is complex. Very hard to difficult, everything is text-based, lots of duplicate of parameters with Kubernetes, because every time we want to enable some feature of Kubernetes, we need to wrap it in a parameter in our chart. So that means that in many cases, even, for example, a Redis chart has more than 200 parameters and 3,000 lines of code, which is, I mean, lots of, it's huge in terms of like maintenance and understanding, and everything needs to be documented. And in addition, most parameters overlap with Kubernetes YAML. So every time we need to expose additional Kubernetes feature, we end up creating an additional version of the chart. So that's Elm, and it has pros and cons. And there's Customize, which is also a very popular tool. It's come built in with Kubernetes. It's template free. So we use the same basic YAML we have in Kubernetes, but instead of like doing a parameterization and templates, we are doing transformation with overlays. So in this example, I have the same file we have with the Tetris, but using Customize, I can, for example, add the label to all the resources. And it's not just adding the label in terms of the metadata, it's also in the selectors. So it's actually make it much more efficient and much more customizable. In addition, I can also create several overlays. So in this version, I created another version of Tetris with a prefix for all the resources, like we have the number 2 and a different image, and also I'm doing a patch for the ingress. And using it, it's very simple. It's actually with the same with the kubectl tool. We don't need to install another tool. So if I'll do like version 2, and let's see our resources, we can see that we have Tetris 2 deployment up to everything is with this addition. And I also have here Tetris 2. And we can see that it's a different game, so because it's a different image. So Customize is very useful for having like several variants of the same deployment if you're doing like production or staging, or if we want to take an existing deployment and override some field, doing like patching. And the nice thing about it is that it doesn't hide the Kubernetes API, and we have several iterative functions that deal with real world cases, but it's very limited. We can create abstraction with it, and there's no story for packaging or external dependencies like in Elm. So in some cases, we use in the past Elm and Customize together. So we use Elm for like rendering the chart and Customize for doing like the overlay. And it was like, not fun. not fun at all. So let's take a step back. What's important, or at least what's important in my opinion? I want to be able to do like good composition that will be declarative. I can use parameters if I want. I can create abstraction. I can do like overlay or patching. I want it to be simple. I want correctors. I want type safety. I don't want to have like these texts and templates that I use in Elm. I want it to be smart. I want it to be testable easily. I want to be able to share my abstraction or my configuration and use external imports and package management like we have some of it in Elm. And I want it to be developer friendly. Good IDE support, familiar programming language, and minimal boilerplate. And there's also security, which is important. So if we look at this definition, we can see that Element Customize don't quite nail my requirement. And I'm going to show a different way to define this deployment, which is nicer. So let's, I'll just delete. Oh, overlay version 2. So I don't have this noise. So first of all, let's talk a bit about Deno. Deno is a way to run TypeScript. We can use it. We have a simple CLI that does all the operation from formatting, linting, testing, running, and everything. So it's we can do everything with the CLI. So it's very nice. I can do like test and formats, and basically it's a way to run Node, but without all the, to run JavaScript runtime or TypeScript runtime, but without all the stuff we get with Node in many cases, like the NPM or tooling or other stuff. Although, and also it's based on different like ecosystem. Okay, and TypeScript is a superset of JavaScript. It has like extremely powerful type system that I'm going to show some example of that. And the idea is that I'm going to use TypeScript to define my deployment and simply render it with Deno. So let's try it. My first example here, I'm importing Kubernetes generated APIs. We can see that we are importing it from a URL. Basically, all the dependencies in Deno, we don't have package management. We just declare the dependencies when we are importing them, whether they are based on HTTP or a file system. And I have here the API of Kubernetes, and I'm using it to create a pod. Notice that I have like a complete autocomplete, description, correctness. I can't do a number here because it won't compile. And that's basically the first example that I saw we saw before. Now, if I'm going to do Deno run, I'm simply going to render a YAML. We create a pod with parameters. So that's simple. Let's see how much further we can take this approach. So here I'm seeing the example with the application that I'm using parameters like labels and metadata, and I'm going to reuse them. So it makes the deployment much more cleaner compared to the deployment I did before with the service. And again, everything is with autocomplete and correctness. And if I want to run it actually in Kubernetes, I simply pipe it to Kubernetes apply. Very, very simple. And again, I can delete it. Now, that's a way to define some code reuse, but if we want to create abstraction, we can also do that. So I created abstraction of an application. So that we can think about a bit like we are doing with the Helm chart, and we define all the parameters, and then we can define the parameters we want. So I'm not dealing with ingress directly. I'm doing like expose hostname. It's very clear. And the good thing about it, compared, for example, to Elm, that we can still do like changes and overlays. So you can notice that I can change the replica number. I can change the TLS. And everything is like type safe. So it's very powerful. Powerful and yet relatively simple. So the example that we had before with the multi-service in YAML, using this approach is actually only 80 lines of code, and it could probably optimize even more. And you can notice that I'm creating a namespace, I'm creating application, but then my application doesn't have, for example, volume support. So I'm just going to edit. And that's something if I was working with Elm, it was very difficult to do because I will need to create like a new chart and then with parameters of volume maps. And here I can do it everything like in line. So it's very easy to do like manipulation. We saw example of writing code in more object-oriented way, but we can also write it in a functional way. So we have like Fluent API. So here I'm creating a microservices with deployment, and here I have the parameters. I'm adding a service, I'm exposing it. And notice that again, the type safety is so powerful that if I'm not exposing it, there's no ingress. So I'll get like a compilation error. And this thing can create additional reusable units. So in this case, I'm creating a blueprint that I'll define some parameters. And again, can also use in this example, I'm actually using a CRD, a custom resource. So here I'm using a custom resource from Prometheus. And again, it's also type safe because everything is generated. And that's a way, for example, to create a reusable component easily, like we think about Elm, but like creating a chart, but again, it's much simpler. Another thing that we have is that we can run unit tests, and it's fairly easy to write. It's like in a regular service. So here for the application object that I created a microservice that checks that the ingress and the service and everything are correlated. So I can create a reusable units that are actually tested. And in addition, Deno has several interesting properties. So here I'm going to import an application, and I'm going to take a function called set namespace from this URL, which has something evil, obviously. But let's say okay, let's try it either way. And I'm going to run it. And you'll see that I'm getting an exception. Now, to understand why we get an exception, we need to look at the code. So this evil function, it exports the set namespace as we expected, but it also do a lot of other stuff like copying my environment variable, getting my SSH data, and sending it to some evil service. And you see that Deno doesn't allow it to run because it doesn't have permission to read environment variables. That's because Deno run by default in a sandbox. So if I want to allow environment variable, I need to add a parameter. But again, we have a problem because we don't have file read access. And it will going to fail again because we don't have network access. So it makes it very easy to secure these kind of properties when we are entering packages or tools to our development environment or CI. Now, it's even more powerful because we can also limit, for example, we can limit the read to a specific folder or the net to a specific domain. So in this case, we would say you have to have allow net with some evil service. So at least it can protect from one vector of attack when we are starting to run tools in our CI, and not unlike other. For example, if we look at the node ecosystem, when I am importing a package, I don't have usually like a direct link to that I can look at the code, because in many cases I'm looking at the code like in the GitHub repository, and it's not necessarily the same data that appears like in the npm package. So it's very nice. Now, another thing in this toolkit is that we can also work on other resources that we are importing. For example, I'm going to import the first configuration I use. So it was, let's take Kubernetes, and let's take the single service for actually, it doesn't that matter. So let's take the multi-service, and we have this configuration with several microservices. Let's, for example, I want to make every deployment spec with like replicas of 2. So I'm going to take that and pipe it to this Deno file. And what's going to happen is going to run across all these resources and change for everyone the replica of 2. And it's very straightforward. We import the resource, we do a traverse on type of deployment, and for each deployment, we have the replica 2. Now notice that it's type safe. So if I'll look here, what kind of resources I can have, you can see that it's only a type of apps v1 in the version of Kubernetes. And if I was using, for example, a daemon set here, we will get an exception because it doesn't compile because we don't have replicas on a daemon set. So it's very type safe, and we can use it for, in this case, for like manipulation. It can also be used for validation. So here I'm for an example. For example, if for an ingress resource, we don't have TLS. And the good thing about it is that it's very simple. So every developer can use it. Every developer, especially developers that already use TypeScript, which is a very popular language, so they can control the flow and do like the manipulation, whether if they are building it directly, whether if they want to create like reusable components. The reusable components can be shared via URLs, which is very simple. We don't need additional pipeline of like NPM and publishing packages. Everything is very clear. So in that regard, it's also easier to share code. And I think that's basically all the examples of Deno. The ingredients of this library I showed is Deno, type generation, and some code reuse building blocks. And basically that's all. It's very minimal. So we'll take question in the end of it. It's not perfect. This project is actually used as an experiment for trying to reduce like a very huge Helm chart. It doesn't cover like all the cases, but it's an open source project. So I'll be happy to hear feedback about it. And when I'm comparing it to the requirements I mentioned before, I think that Deno covers most of this requirement in a good way. And some of them like in amazing way, the way I see it. And I'll summarize. First of all, I will say that there are many benefits of using a real programming language for configuration, especially as we see that like this shift left approach that we are giving more responsible to developers. In many cases, they prefer to use a real programming language and not some configuration language which is limited and have very poor composition or code reuse and abstraction capabilities. We actually see it with other products as well. So Pulumi offer this capability with different programming language and not just for Kubernetes. And they are sort of like, I think they are the one that made it mainstream, this approach. Also, AWS have a similar capability with CDK and CDK for Kubernetes. And also there's a tool called JKCFG, and I'm sure there are other tools as well. I think the reason why Deno is interesting is because compared to the other tools, it doesn't have like dependencies or boilerplate. It's very easy to use. We just need a CLI. You don't need a TS config. You don't need an NPM. You don't need to create additional pipeline for applying your configuration. It has strong and flexible security. The code reuse there is, I think, the simple it can get. You can use like your GitHub repository and just import stuff from there, and it will work very well. And it also gets like good ecosystem and tooling. So it's very easy to get started and get to value. And I'll talk a bit about this library that I'm using here. So it's about an open source, and you can import it and use it like in a second. It's a toolkit. It's not a framework. It's designed to do like this manipulation, print it. It's not optimized for a specific flow, and it doesn't do stuff like the reconciliation algorithm if we look at tools like Pulumi. And I think it's a good thing that it's simple, because I mean, it can easily integrate it with other tools. So if you use like tools like Tilt or Argo, the fact that the output is a regular Kubernetes YAMLs make it very easy to consume. It's open source, as I mentioned. There's a link here. Yeah, I think this approach can be not used only for Kubernetes, other as well, but we need to generate the types. And I think that in the future, we'll see more projects that provide different way to do configuration in languages that are much more powerful, even if they are like the next generation of configuration language, as we see with Q or DAL, which are very interesting projects. And I believe that that's it. I think in general, the aim of this talk is to help you see ways to do deployment in a simpler way. And I think that as a developer, we should always strive to make things cleaner and simpler. And that's all. Thank you.
All righty. Thank you very much. That is something what I learned again, so something new. So thank you very much for that. Let me share my screen with the questions. So
sure.
We have 2 questions. I think one of them you kind of answered already, but the question number 1, are there any advantages of using Deno versus Pulumi with TypeScript?
So basically, I use Pulumi with TypeScript quite a lot. I think that it's like amazing product, but when using Pulumi with Kubernetes, in many cases, it's simply more complex. And you see it in cases that you want, for example, to integrate it with a tool like Argo, or tool like Tilt for local development. At least the experience I got is that they have like the Pulumi files for deploying production, and YAML files or some other format or usually it could be like YAMLs and customized for development locally. So I think the problem with Pulumi in this case that it's like a full framework, and it doesn't necessarily play well with using Deno, which is just a way to generate configuration file. And for Kubernetes, you don't need in many cases much more than that, because you don't need to build DAG in many cases, and the reconciliation is happening in the cluster, not in your CLI.
All right. Can the Deno capabilities be restricted to the local code versus remote imports?
So that's a great question. Unfortunately, it can't. It's something that I was curious about it myself. So as far as I know, and I checked it like a few months ago, it's not possible yet. I'll hope that they will support it in the future.
Okay. All righty. I think we will get to our we will take a break. We will take a 10 minutes break. So and we will sorry, we'll take the 10 minutes break, have something to drink, have something to eat, and we'll come back in 10 minutes to 8:30. for David for last our speaker for today. So yeah, hopefully I will see you after break.
Thank you.
8:30, and time to our last speaker, David, to join us and to tell us about the debugging of the Kubernetes. So hello, David, how are you?
Yeah, I'm doing all right. Thank you. Going well.
Okay, I hope you are ready. So please, stage is for you. And hopefully we will learn something, another good things to do today.
Well, I can't promise anything, but I do hope so. Oh, thank you.
All right, go ahead.
Thanks a lot. All right, so let's start off with a quick introduction. I'm going to make this really brief, as time is against me here. So my name is David Flanagan. You may know me as Raw Code. That's my handle across the internet. I do a lot of live streaming on my YouTube channel, which you can check out at rawcode.live. And today's session is actually a slightly modified version of my clustered streams, which I'll talk about in just a moment. I am the host of the official Kubernetes office hours. So once a month, I try and help people with Kubernetes with a great panel of Kubernetes community members. If that's something that interests you, please reach out. And I am a CNCF ambassador. I also work for Pulumi as a staff developer advocate. I specialize in GitOps, platform engineering, and Kubernetes. The Klustered is the worst idea ever, of course. I had this idea over a year ago, and we're now over 30 or 40 episodes in at this point. I've lost count. The idea is I provision bare metal Kubernetes clusters and give them to people from the Kubernetes community and ask them to break them. Typically, I have other people join the session and attempt to fix the clusters with help and guidance from myself, but today I'm doing this all on my own. Normally, fixing a cluster takes anywhere from 45 minutes to 90 minutes, but I'm going to attempt to fix today's cluster in under 30. I just want to say thank you at the start to Russell, who is in the chat and on Twitter as I work with Homer. He broke today's cluster for me, so I'm thanking him now because I'll hate him by the end. I also want to thank Equinix Metal, who provide all the hardware for these sessions. So thank you very much. And I'll be using Teleport today to debug this cluster. If you want to learn more, there is a link. And if you want to join the community, there is a chat. All right, let's go fix the cluster. So I'm going to show you how I would debug a real broken cluster. I found this to be a really invaluable way for people to learn and pass their CKA exam, because there is a whole lot to learn, as has already been covered by the two other speakers today when it comes to Kubernetes. Let's jump on to the control plane node here. Now, kubeadm or kubeadmin, depending on how you wish to say it, is the de facto way now to spin up a cluster. As such, we know that we're going to have a Kubernetes, etc., or a /etc/Kubernetes directory, which is going to have an admin.conf typically, at least on the control plane node. And we can use that as our kubeconfig. So we can configure our client like so. This is a fun bit. The first thing most people do on Klustered is check to see if we have a working API and control plane. And running get nodes, get pods, whatever you like, is a really good way to see if that works. And it looks like we have one. We get a response from get nodes. It looks like this cluster isn't that broken. Of course, things can be very deceiving or deceptive. The mission on Klustered, we got Russell, the hatred is growing already. We can see that he's starting messing with stuff here. We have a whole bunch of random pods that we don't expect to see here. So let's take a look at that get pods again, only looking at our default namespace. Now, the mission on Klustered is we have a sample workload, which actually is a small video of me looking at my watch, and we want to upgrade the application to me doing a small dance to celebrate our impending victory. It would appear that our cluster deployment is broken, as well as our Postgres deployment, which is required for the application to work. So it's not that we just have to upgrade our application. We have to ensure the cluster is in such a healthy condition that networking and services will also work. All right. All those extra pods are a little bit daunting, but I want to see if I can work out where they're coming from. So if we run get deployments, we can run get daemon sets, and we can run SDS just to see if there's anything out of the ordinary from the basics here. I didn't really expect any of them to show anything because we're not really getting a tuple here that would make me think that these are real pods. And in fact, I think that potentially our control plane isn't what it seems to be, although it's kind of hard to tell at this point in time. Now, the way to check your control plane on a Kubernetes cluster is to go to Kubernetes manifests. And this is where the control plane components live. They're called static manifests. They live in a directory, and the kubelet is responsible for starting each and every one of these YAML files. And it creates something called a mirror pod, which is a reflection of the static manifests themselves. Now, based on the timestamps, which mean nothing on Klustered, but I'm going to trust Russell for today, I don't think this has been modified. These are all the timestamps that I would roughly expect to see at this point in time. However, the question I gave you at the start of today's session was about the controllers, and I just want to show you this line here. This is a good fun one. -- controllers. We can see that star means run every controller. We're adding, or at least the defaults, we're adding a bootstrap signer and a token cleaner. And you can disable controllers with a minus like that. Always great fun. But I'm going to assume our manifests here have not been touched. If I get stuck today, Russell has been very kind to leave me some hints inside of the root directory, which I will be using quickly and fast if I need to, so that we can try and finish this session on time. But let's get back to our conundrum here. We've got a lot going on here, and I'm going to try and describe one of these to see if that is even possible. Now, I said it wouldn't be, I said that it wouldn't be a deployment or daemon set because, or stateful set, because I'm not really seeing the tuple that I expect. However, actually, I was wrong because the node and name at the end would indicate that this is potentially spun up to a manifest in the static directory, or maybe as a daemon set. I could have been wrong. But let's see what we've got here. So this potentially is. All right. What I'm going to do is, in fact, what are the sizes like on these files? So our controller manager file and our kubeAPI server potentially a little bit big, but I don't think there's anything nefarious here. So really, I'm actually a little bit stumped already, as I'm not sure how he's got these pods here. Now we can run kube control get all and see if anything else comes back. We have a stateful set, a replica set, a deployment. Nothing particularly out of the ordinary. So I'm going to try and delete them to see what happens. But if I describe one again, and see if I got any common labels to use for my deletion. No, thanks, Russell. Another thing that's worth checking here is wide on get pods to see where these are actually scheduled. So we can see worker 2, worker 2, worker 2, worker 2. Okay. All of those are scheduled on worker 2. So we're going to pop over there and poke around. Let's just teleport, hop over. We've got our Kubernetes directory. We've got our manifests. And we have a whole bunch of files here. So these are, in fact, static manifests. And the hint that I should have clocked on sooner was the node name on the end with worker 2. I'll take a look at one just for the giggles. All right. And I'm going to nuke. There's a Docker file in there, Russell. Really? We will delete all of those. I'm just going to delete everything. It doesn't matter. I'm hoping what we'll see now is that the kubelet will detect that the pods were removed from the static manifest directory, and this should start to clean up. However, if we remember to get nodes, our worker 2 isn't actually healthy. So we're going to have to fix that first, and it could be that our kubelet isn't running. The kubelet runs through systemd. So we can do a status here. It does actually look, it does kind of look all right, I say, but then I can see it's been running for 4 seconds. So perhaps not. So let's run a PSAUX, which is just how I like to look at Linux systems. And I can see that our kubelet has been running for a very short period of time. So I suspect that something has gone wrong. And right off the bat, I see something fishy here. We actually have some reserved CPU and memory constraints applied on the kubelet, which look a little bit out of sorts. And that's just something that I've come to be familiar with as I fix broken Kubernetes clusters. So the way that we can debug this, system control cat is one of my favorite commands. We can run this and it will show us all of the configuration used by systemd to run our kubelet. Now, in our kubelet service, there's nothing out of the ordinary here. This looks all right. And if we pop down to here, we've got a drop-in called kubedm, and I don't see, although this could be a pager issue, anything there that fills me with regret. But we do have this environment file that we probably want to take a look at. So let's take a look. Oh, and it's empty. All right, I'm going to run that cat again with a no pager. I don't have a pager, all right. Let's take a look at this config file instead. Cool. So kubelet is configured by a manifest, just like everything in Kubernetes. And we're looking for something to do with memory. It looks clean. It looks clean. Let me confirm my hypothesis again. Oh, we don't have a kubelet running. There we go. System reserve. Yeah. Okay. So I really need to find out where Russell has set this on my kubelet. So I'm going to run the cat again. And did I miss any files? There's a flags one here that I didn't look at. And there's, all right, let's just work through these one by one. Oh, there we go. So this has been modified. We have the system reserved CPUs. This is a flag that allows you to make sure that the Kubernetes system doesn't eat up all of your CPU and memory, which is not doing me any favors here. So we're going to delete that. And it looks like pod info container. I don't think that's a bad thing. So I'm going to leave that one there for now. I may regret that decision. We're now going to check the status of our kubelet to see if it's now surviving a little bit longer. I believe what was happening here was that because of that system reserved memory flag, the kubelet wasn't able to run long enough and was being almed essentially and restarted on a very regular cadence. We can now see that it's been running for 20 seconds. I think that's an improvement on what we had so far. And I'm going to run get nodes again to see if that looks any better. And it does. So in theory, if I run kube control get pods, I'm really hoping that the static manifests that we deleted from the worker 2 that were started initially by the kubelet before the kubelet was broken and then couldn't clean up itself are gone. Whew. Okay, so now we've got another problem, and that our clustered deployment and our Postgres pods aren't running. They're stuck in a pending status. So I'm going to do a describe pod, and we're going to, I should really enable my autocomplete, but I'll try and get by without it for now. And we're looking for the events. Now, one of the most important things is, one of the most important things with describing resources in Kubernetes is generally this event here. But we have none. So this is going to be a little bit trickier than we were hoping for. The next thing, pending, there's only so many things, right, that this pending status can mean. Typically, it means the scheduler's not running or the pods couldn't be scheduled. It could also mean that the CRI is unable to pull down the image. So we're really looking here to see, do we have a node assigned when I describe this? So if I do a grepi for nodes, we can see that this actually was assigned to a node. So it did get past that, which makes me think that the problem here is a kubelet or container deconfiguration on, well, I'm going to go take a look at worker 1. Let's jump onto worker 1. And I'm going to run a PSAUX, and I'm going to grep for our kubelet or any random flags. Yeah, we've got the same here. And I'm also going to take a look at containerd, which is our CRI, to see if there's anything potentially suspect here. I don't think there is. I think that's all right. So I'm going to assume that this pause thing here, which typically is, we use the default, we don't overwrite this value. Potentially the pause version 3.5 doesn't exist, which is causing us to be stuck in our pending state. So I am going to modify, oh, I don't even remember where that file was. Cat kubelet. It was this, no, it wasn't that one, was it? It was flag ends. There we go. And I'm going to take it off this time. And I'm going to delete our pending pod, force it to reschedule. Hopefully we get worker 1, but I may have to make the same change on worker 2. Modifying that file, the kubelet should reload, but you can use daemon reload and restart just to hurry that along a little bit quicker. Okay, where's my control plane? Oh, that's my worker. But just because I'm here, I'm going to make that change as well. We're not going to override the pause container. Russell, if you're in the chat, you can confirm whether 3.5 even exists and whether you made that change. But just the control daemon. Ah, the time pressure is getting to me. I've got 13 minutes. Restart. Cool. So I'm going to come back here and run get pods. Oh, look at that. We have a container creating. So we know that, I mean, okay, here's something that's interesting. The pause container actually sets up a sandbox with the C groups and namespaces. If the CRI implementation can't build on that pause container, you're never going to get that sandbox and the container can never be created. I'm hoping that right now, my image is being pulled. He didn't touch the pause container. Russell's in the chat there, which he's now got me a little bit worried. Okay, so I'm going to describe clustered now and see where we are, because we do have a different status now. And it is pulling my image. So this actually looks good. So I guess the challenge was Russell also set those system memory constraints on the other worker, which is just unfortunately where my workloads were scheduled, which is probably why they were stuck in pending and couldn't be made. And the pause container wasn't really important whatsoever. In fact, I potentially made it worse by removing that pod thing. And now that we're not getting it. So I wouldn't have expected this to be pulling for 90 seconds. I actually expect that image is on the machine. And we can try if we have CTR. No, we don't have an image. Now, because Russell says he didn't touch the pause thing, I'm going to add it back really quickly, if I can remember what the line was. Although I think the default should be all right, if it has one. Pop this back. And that's a common thing on clusters, to be fair. I do make assumptions and break things more than I fix them, which is unfortunate. Okay, daemon reload. I'm trusting you that you didn't modify that flag. I'm going to force a quick delete of all these pods in this namespace, just to, I don't have my aliases. Delete pod on. There we go. And then we'll run a kube control get pod watch and see if we get any further. So we're back to pending again. 11 minutes. Okay, we got this. Let's describe our pod again. So we've got no events. We're not scheduled. That's a challenge. Maybe you did break the scheduler. Okay, so how does the scheduler work? Well, we take a look inside the kube system namespace. Aha, there we go. We don't actually have a scheduler. So we need to fix that. We can ignore the kube bit, and that's a bug in my automation. We don't need to worry about it. So let's go into the manifest and take a look at the scheduler. And I'll show you my favorite trick. All right, we don't have a Kubernetes v22, right? But before I fix the scheduler, Here's a kill trick. Edit deployment clustered. The scheduler doesn't really do an awful lot besides work out where to put things. To the point where you can actually come to the pod template and hack it. So I can do, what is it, spec, template, spec, and we can just put node. Is it node name? I can't remember. CN London worker 1. Yeah, that wasn't the right place. I mean, I can never remember where to put it. Put it on the pod. So spec, template, spec, node. And it may be node name rather than node. I always need that. There we go. So now if we run get pods, we'll actually see that this is scheduled, even though we don't have a working scheduler. But we do know what's wrong with the scheduler, so let's fix that too. Russell just modified the image. So we can check our scheduler is working with a get pod, and our scheduler hasn't been restarted by the kubelet yet. So we'll stick a little watch on that and give that just a moment. Where's my scheduler? All right, let's check on our workloads. We'll come back to the scheduler. We've got time. Our clustered one is running. Perfect. Now, the Postgres one should work if our scheduler comes back. But it would appear it's not. Excuse me. Because it's also not GitHub container registry. These live on GCR. So that image wouldn't have been able to get pulled either. Sneaky. Come on, give me a scheduler. Now the kubelet automatically detects the text change to the static manifest. However, it can take, sadly, I think up to 4 minutes before it detects that change. I could go check a look at the kubelet logs, which live in journal D, and see what's happening here. Now we've got some kubevip errors, which is annoying that I left that broken. However, I don't really see anything wrong with my scheduler. So we'll run get pods again. I still don't have a scheduler, but I'm going to take a sledgehammer approach and just quickly restart my kubelet rather than debugging this kube scheduler manifest. And we'll give us 3 more minutes before I start looking at the hints to see what I've missed. But I feel like we are super close. And in fact, I can just schedule this myself as well. So let's edit our stateful set for Postgres. And we'll add our node name here. London worker 1. Just try and encourage that too. There we go. So now that should start running in just a moment. Let's quickly check our scheduler again now that the kubelet's been restarted. And it's in crash loop back off. So we can go to var log containers and we can take a look at the logs for our kube scheduler. We have none. Where is it scheduled? Good question. I'm talking to myself now because it's the best. Okay. The scheduler is on the control plane node. Well, yeah, because this is static manifest. I'm being very, very silly today. Where's my logs? All right. Get panicky. But we've got 6 minutes. So I'm still confident. Describe. See what's going on here. What even is that typing? Describe pod. Now it's not the incorrect image because we get a crash loop back off, which means the image is pulling Now, it's not the exact version of Kubernetes. I probably should be using 122.4. I don't think using a point version different is going to cause the problem. But again, I don't need to worry about that. I'm not going to try and fix it. We actually have everything running now. So I'm going to pop over to Teleport. I'm going to hit applications, and we have the clustered application exposed as a Teleport application to security access. So let's have a look. Am I going to get the video of me on my watch? And I am. 35 seconds. All right. Russell has rickrolled me. Thank you. All right. Let's edit our deployment. Clustered. I'm on the worker. 4 minutes. Edit deployment. Clustered. Go to the image. All right, so this is the correct image. However, it's pulled something completely different. So I'm going to do one of two things while I debug this. First, I'm going to ensure that we have the image pool policy as always. So I'm going to take a look at the containerd config dump, which isn't there. So he's not used containerd to tweak the alias for that thing. And the image path is correct. And I've got 3 minutes. How can he modify the image that runs on this machine with an image pool policy of always? The containerd config could be on the other machine. The config dump. It's not. All right. GHCR is where I host the clustered images. So that is 100% correct. I didn't notice any typos. Russell has in the chat is telling me to read hint 4. Let's see a different video and then extra quotes. Yeah, I did that. Even if you hit blah, blah, blah. A raw code smash won't fix this. Something triggers this change. Okay. So there are a couple of ways to enact change within a cluster. And if we do, I've got 2 minutes. Describe, get pods. Describe pod. We're going to see the image hopefully has changed, which means it's probably going to be an admission controller. Let's have a look. Perhaps not. However, I'm going to check anyway. Give control, get mutating admission webhook configurations. What are they called? Webhook. Kube control API resources as your friend. Grab for mutating webhook configurations. Kube control. Get. Let's have a look. We don't have a mutating webhook configuration, so it wasn't that at all. All right. I'm just going to check the hints because I don't have enough time. I've got 1 minute. So hint 4, and the answer should be in the .1. Okay, I am modifying the image. Every time you run a command, you also overwrite the video file, the envar prompt command. All right, so sneaky, very, very sneaky. So Russell has modified the environment that I'm running my kube control commands to actually go and replace the video inside of the image. There we go. So I'm going to remove this and just have it say echo hi. I will run get pod. We see the echo hi there. Very sneaky. And I'm going to delete our cluster pod, which should fix everything. And let's go see. And I should have it 10 seconds left. So we got our application running again. And we got the dance right on time. Good job, Russell. That was a good break. Thanks a lot.
Every day something new. That's you know, big clap. That's very, very impressive.
That was tense. That was really tense.
Yes, one of the things what it's very interesting is just like how we can hide the kind of changes. So from the security point of view, it's very good to see what can go wrong with the full permissions, if I can say like that. So let me share the last time of my screen. This is a question for David. If you want to raise the question, please on the below on the video there is a Yshay/p link that so you can. I think we will give the 1 more minute to see it. You said that you are also streaming your debugging.
Yeah, Klustered is a series on YouTube. You can find it at rawcode.live. There is over 50 broken clusters there being fixed by myself, broken by members of the community, and even fixed by members of the community. Russell, who broke this cluster, has been on a few episodes himself. So it's not just my debugging you get to see. You get to see the debugging of some really prominent members of the Kubernetes community, see how they think and how they tackle these problems.
Interesting. That's awesome. So when is next Clustered episode?
Klustered will be back next week on Thursday.
Awesome. Fantastic. All right, then. I think that we will finish on that note. Thank you very much for the presentation. Thank you, everybody, for joining us today for the Cloud Native London. I will probably see you in February. To be confirmed the date. You can always book select on the YouTube the value to remind you. Please leave a like because it helps to find it. Subscribe if you do not want to miss any of the future Cloud Native London meetups. Leave a comment and hopefully have a wonderful January of the 2022. Right. Thank you very much, everybody. Have a good night.